proposed in space propulsion technologies describe the propulsion technologies that could meet future space science and exploration needs. These propulsion technologies are intended to provide effective exploration of our solar system and will permit mission designers to plan missions to fly anytime, anywhere, and complete a host of science objectives at the destinations, and with greater reliability and safety. With a wide range of possible missions and candidate propulsion technologies, the question of which technologies are best for future missions is a difficult one. A portfolio of propulsion technologies should be developed to provide optimum solutions for a diverse set of missions and destinations. In-space propulsion begins where the upper stage of the launch vehicle leaves off, performing the functions of primary propulsion, reaction control, station keeping, precision pointing, and orbital maneuvering. The main engines used in space provide the primary propulsive force for orbit transfer, planetary trajectories and extraplanetary landing and ascent. The reaction control and orbital maneuvering systems provide the propulsive force for orbit maintenance, position control, station keeping, and spacecraft attitude control. A large fraction of the rocket engines in use today are chemical rockets. That is, they obtain the energy needed to generate thrust by chemical reactions, to create a hot gas that is expanded to produce thrust. A significant limitation of chemical propulsion is that it has a relatively low specific impulse, which is the ratio of the thrust produced to the mass of propellant needed at a certain rate of flow. A significant improvement in specific impulse can be obtained by using cryogenic propellants, such as liquid oxygen and liquid hydrogen, for example. Historically, these propellants have not been applied beyond upper stages. Furthermore, numerous concepts for advanced propulsion technologies, such as electric propulsion, are commonly used for station keeping on commercial communications satellites, and for prime propulsion on some scientific space missions, because they have significantly higher values of specific impulse. However, they generally have very small values of thrust, and therefore must be operated for long durations to provide the total impulse required by a mission. Several of these technologies offer performance that is significantly better than that achievable with chemical propulsion. In-space propulsion represents technologies that can significantly improve a number of critical aspects of the mission. Space exploration is about getting somewhere safely, getting there quickly, getting a lot of mass there, and getting there cheaply. The simple act of getting there requires the employment of an in-space propulsion system, and the other metrics are modifiers to this fundamental action. Development of technologies will result in technical solutions that improve thrust levels, ISP, power, specific mass, volume, system mass, system complexity, operational complexity, commonality with other spacecraft systems, manufacturability, durability, and cost. These types of improvements will yield decreased transit times, increased payload mass, safer spacecraft, and decreased costs. In some instances, development of technologies within the star will result in mission-enabling breakthroughs that will revolutionize space exploration. There is no single propulsion technology that will benefit all missions or mission types. The requirements for in-space propulsion vary widely due according to their intended application. The described technologies should support everything from small satellites and robotic deep space exploration, to space stations and human missions to Mars applications. The technology areas are divided into 4 basic groups: chemical propulsion, non-chemical propulsion, advanced propulsion technologies, and supporting technologies, based on the physics of the propulsion system and how it derives thrust as well as its technical maturity. Additionally, there may be credible meritorious in-space propulsion concepts not foreseen or reviewed at the time of publication, and which may be shown to be beneficial to future mission applications.